Good evening, everybody. We are supposed to solve sum number 12, but in the beginning, we discuss sum number 15. After that, we will solve 12, 13, 14. Now, sum number 15, this is a good one. A window is in the form of a rectangle surmounted by a semicircle. If the perimeter be 30 meter, find the dimensions so that greatest possible amount of light may be admitted. You have to just listen to me. You can write the solution afterwards. Let x be the length and y be the breadth of the rectangle and r be the radius of the semicircle. Then the perimeter of the window will be what? It will be x plus 2y plus this half circumference, that is pi r. Now this is given to be 30 meter. So we use this condition to express y in terms of x. So what is y from this? It is 15 minus pi plus 2 into r upon 2. I'm sorry. Here x is nothing but 2r because diameter is nothing but that length. Okay. So we have obtained a function entirely in terms of r. Good. Now the greatest possible amount of light may be admitted if the area of the window is maximum. So which function we have to examine for maxima? Area. Now can you tell me what is the area of the window? It is this area of the rectangle plus area of the semicircle. So it is xy plus pi r square upon 2. That is 2yr plus pi r square upon 2. Now we differentiate this, or this is further simplified to get what? 30r minus pi plus 2r square plus pi by 2r square. Okay, because from 1 what is y? This is 15 minus pi plus 2r upon 2. Because we need univariate data. Now this is a, so that what is dA/dr? Find the derivative using usual method. Differentiation is not at all difficult. So this is dA/dr. Okay. Then for maxima, dA/dr should be 0. So 30 minus pi plus 4 into r is 0. So r comes out to be 30 upon pi plus 4. Before that, second derivative is to be obtained. Let me see whether second derivative is obtained or not. Okay, second derivative is not shown here. Okay, when I'll upload the file, I'll write that part also. So this is second derivative. At which point? At r equal to 30 upon pi plus 4, you will notice that it is minus in bracket pi plus 4. Can we obtain the second derivative orally? Let me see. Yes. See, this is dA/dr. 30 minus pi plus 4 into r. So it is d2a by dr square. Derivative of 30, 0. Minus pi plus 4 is constant. What is derivative of r? 1. So it is second derivative minus in bracket pi plus 4. Always negative, right? But we want derivative at which point? R equal to 30 by pi plus 4. So at that point also it is negative. So area is maximum when r is 30 upon pi plus 4. Now when r is 30 upon pi plus 4, what is length? It is 2r, that is 60 upon pi plus 4. And what is y? Y is 15 minus this, okay, from 1. Let us see what is 1. Yes, y is 15 minus pi plus 2 into r upon 2. So we have to substitute the value to get y as what? 30 upon pi plus 4. Hence, the required dimensions of the window will be what? Length of the rectangle 60 upon pi plus 4 meter, breadth of the rectangle 30 upon pi plus 4 meter, and radius of the semicircle is what? Half the length, because this length is nothing but diameter. So it is 30 upon pi plus 4 meter. Okay, this is not at all difficult. Sum number 12. An open box with a square base is to be made out of given quantity of sheet of area a square. Show that the maximum volume of the box is a cube upon 6 root 3. I'll read the problem again. Open box with a square base, okay, is to be made out of given quantity of area a square. show that the maximum volume of the box is a cube upon 6 root 3. Okay, write down. Write the solution. Let x be the side of square base. Let x be the side of the square base and h be the height of the box. Small h be the height of the box. See, the box is to have an open top. Okay. Then x square plus 4xh is nothing but a square, because what is total surface area? It is 4 times area of the rectangle, right? Side faces. So 4xh plus area of the base, which is a square of side x. Now from this, tell me what is h. See, we use this condition to eliminate one of the variables. So it is a square minus x square upon what? Upon 4x. Okay. You can say this is number 1. Write down. Now volume of the box is, yes, what will be the volume? What is formula for volume? It is area of the base into height. Now base is a square of side x, so it's area x square into h, right? That is x square. Now put the value of h and simplify. So this is a square minus x square upon 4x. So finally 1x gets cancelled. So it is a square x upon x cube upon 4. Now this is the function which is to be examined for what? For maxima. Okay. So this is f of x. Now you know the next procedure. Find out first derivative, second derivative. What is f dash of x? It is a square minus 3x square upon 4. What is f double dash of x? Minus 6x upon 4. Finding derivative is not at all difficult. So this is second derivative. Okay. Now what next? We solve the equation f dash of x equal to 0. So I will say now f dash of x equal to 0 gives, what does it give? It gives a square minus 3x square upon 4 equal to 0. That is 3x square equal to a square. Find out. So x square is a square upon 3. So what is x? Plus a upon root 3. Reason, x is greater than 0. Okay. So x equal to a upon root 3. Now at this point, we have to verify whether second derivative is positive or negative. So what is f double dash of a upon root 3? Put this in f double dash of x. What is f double dash of x? It is minus 3 upon 2 into x. So minus 3 upon 2 into a upon root 3. Clearly, this is negative, less than 0. So you have to say, therefore, you have to write full form. By second derivative test, function has maximum at which point? At x equal to a upon root 3. Okay. Now what is asked? We are asked to find the maximum volume. So there are two ways. We have obtained volume entirely in terms of x. So put that value. Otherwise find out h and then use the result. Same thing. Now we are not asked to find the height. Okay. So V max is nothing but value of the volume function at A upon root 3. So let me just check what is that function. So that is x square into a square x square upon 4x. That is what? A square x minus x cube upon 4. Okay. So that is a square x minus x cube. So a upon root 3 cube upon 4. Now simplify this and tell me what is the final answer. Simplify this. You should get a cube on simplification upon 6 root 3 cubic unit. Sum number 13. This is again good one. Show that of all rectangles inscribed in a given circle, the square has the maximum area. Actually, if this is asked as a MCQ, then you should know that for maximum area, rectangle should be a square, and for minimum perimeter, rectangle again it must be a square. Okay. So just draw the rough sketch, or before that I'll explain. Suppose, don't write, suppose ABCD is a rectangle which is inscribed in a circle of radius r. We take AB as x and BC as y. Okay, so what is x square plus y square? It is AC, that is diameter square, so 4r square. So using this condition we express one in terms of other. Okay, right up. First draw the rough sketch. Draw the sketch. Finished? Okay. Now, here we are not asked to find the maximum area and all that. Okay. So we are just asked to verify or show that the area is maximum when rectangle is a square. Okay. Right now. Let ABCD be a rectangle. Let ABCD be a rectangle inscribed in a circle of radius r, let AB equal to x, let AB equal to x and BC equal to y. Then x square plus y square equal to 4r square. That is y square equal to 4r square minus x square. Now area of rectangle equal to xy equal to x into, see it is y, so I should say root 4r square minus x square. Okay. Now see the change. I am considering square. See the difference between earlier sums and this sum. In this case also, if you consider this as the original function, no problem. You will get the same answer. But to avoid root, see what I'm doing? I'm squaring this. So x square into what? 4r square minus x square. I represent this by fx, right? Now it remains the same. Actually, problem remains the same because I'm considering this part only and I have just squared it. Now tell me what is the derivative? Before that I simplify this. What is f of x? Instead of finding derivative using product rule, I open the bracket. So 4r square x square minus x raised to 4. Now what is f dash of x? Can I write this as 8r square x directly? What is derivative of x square? It is 2x. Yes. Minus what is derivative of x raised to 4? It is nothing but 4x cube. Okay. So this is f dash of x. Find out f double dash of x. F double dash of x is 8r square minus 12x square. Now f dash of x equal to 0 gives, tell me the value, 8r square x minus 4x cube equal to 0. That is, what can be taken common? 4x can be taken common. Okay. 4x can be taken common to get in bracket 2r square minus x square equal to 0. As x is not equal to 0, 2r square minus x square must be 0. That is, x square equal to 2r square. So what is x? It is plus root 2r. Reason, x is greater than 0. Simple. Okay. Next. Now we have to verify whether second derivative at this point is positive or negative. So f double dash of root 2, r is outside that radical sign. So it is what? It is nothing but, have we obtained? Yes, we have. It is 8r square minus 12 root 2 r bracket square. So find out, it is 8r square minus what? Root 2 square is 2, so minus 24 r square, which is minus 16 r square, which is less than 0. Therefore, by second derivative test, function has maximum. Function has maximum at x equal to root 2r. Now don't say that, but sir, square of the area is maximum at x equal to root 2r. If square of the area is maximum, area is also maximum at this point. Okay. So what is y then? So y equal to root of 4r square minus x square, that is 2r square. So it is a root of 2r square, which is again root 2 into r. Therefore, conclusion is, for maximum area, of rectangle, maximum area of rectangle, length equal to breadth. Okay, that is rectangle must be a square. This is what we are asked to prove. That is rectangle is a square. Right now. Sum number 14. Show that a closed right circular cylinder of given surface area has maximum volume if its height equals the diameter of its base. Okay. Write down. Let R be the radius of the base. Let small r be the radius of the base. H be the height. H be the height of the closed right circular cylinder. Closed right circular cylinder whose surface area is given. Whose surface area is given. Now we can take it as k, or we can take it as a square, because finally we are supposed to prove that the volume is maximum when height is equal to diameter of the base. Okay, so what should we take? Okay, next line. Therefore twice pi r h, see this is curved surface area, plus twice pi r square equal to, I take this as a square given, so it is constant. You could have taken this as k also. Okay, so what is given? See, show that a closed right circular cylinder of given surface area. So surface area remains the constant. H and R may vary, but twice pi r h plus twice pi r square remains the same. Okay. Now we use this to eliminate h. Now see how h can be eliminated. First, we can take what can be taken common, or I write this as h equal to, see, h equal to what? A square minus twice pi r square upon twice pi r. Is this correct? Just check this. Yes. Or you may say that this is a square upon 2 pi r minus just r. Okay. So we use this condition to express height in terms of base radius. Good. Now what is the formula for volume of cylinder, right circular cylinder? Now write down. Volume is, yes, what is the volume? Volume of right circular cylinder is V equal to pi r square h. That is pi r square. We have just expressed h. So use that, a square upon twice pi r minus r. Now open the bracket and you will notice that this is what? Half a square r. Just check this. Half a square r minus pi r cube. Is it correct? Yes. Now I will not say this is f of x. I will say this is f of r. or you may write this as V equal to, so that you will obtain what? dV dr. Same thing. Okay, good. Now find out f dash of r, f double dash of r. What is f dash of r? Half a square minus 3 pi r square. Now you will understand the reason why I have taken a square and not as k. But even if you take k, final answer will be the same. Okay. What is f double dash of r? It is minus 6 pi r. Simple, because r is variable, right? Now the next step is, now f dash of r equal to 0 gives half a square minus 3 pi r square equal to 0. Now from this, find the value of r. Therefore 3 pi r square is nothing but a square upon 2. So r square is a square upon 6 pi. So r equal to a upon root of 6 pi. We have considered positive root because r is greater than 0. Is this correct? Yes. Now you have to find second derivative at this point. F double dash of a upon root of 6 pi. Basically, what is second derivative? Second derivative is minus 6 pi r. So minus 6 pi into a upon root of 6 pi. You need not simplify this. Directly say less than 0. And therefore, by second derivative test, function has maximum. Function has maximum at which point? At r equal to a upon root 6 pi. Now this is not asked. We are asked to prove that volume is maximum when height is the same as diameter of the base. Okay. So let us find out height. H equal to, just for a moment. What is H? A square upon 2 pi r, okay, minus r. Fine. So we have to substitute value of r in that. Therefore, H equal to a square upon 2 pi into a upon root of 6 pi. You have to be very careful. Minus a upon root of 6 pi. Now simplify this. So this is nothing but what? Root of 6 pi into 6 per 1 minute. Root of 6 pi, a outside the radical sign, upon 2 pi. Is this correct? Okay. Minus a upon root of 6 pi. So what is difficult? Subtraction of fractions. So what is LCM here? LCM, safer side, I will say 2 pi root 6 pi, maybe cm, common multiple. Okay, so what is the numerator? Numerator is now 6 pi a, 6 pi a minus 2 pi a, 2 pi a. So what remains? 4 pi a upon 2 pi root of 6 pi. Okay, so the next step, h is now 2 gets cancelled. So can I write this as 2 pi also gets cancelled, a upon root 6 pi, but this is nothing but r, a upon root of 6 pi. So we have proved that h equal to 2r. That's it. Right up. Now after this you have to write in words. Therefore, volume is maximum. Volume is maximum if height is nothing but diameter. That's it. See, you have to repeat the classwork. There is no other homework. Okay. So this is the result. Now sum number 16, just listen to me. Show that the height of a right circular cylinder of greatest volume that can be inscribed in a right circular cone is 1/3 of that of the cone. I repeat the sum. Show that the height of the right circular cylinder of greatest volume that can be inscribed in a right circular cone is 1/3 of that of the cone. Now this is, you can say, D group sum. D means difficult. See the diagram. Given the right circular cone of fixed height h and semi-vertical angle alpha. See, not this. This is called as semi-vertical angle alpha, which is usually denoted by alpha of the right circular cone. Let capital R be the radius of the base and h be the height of right circular cylinder which can be inscribed in that right circular cone. Okay. Now in the figure, angle GAO equal to alpha. Okay. Angle GAO. See, this is G, this is A, this is O equal to alpha. OG equal to R. See, small r is the base radius of cone. OA is H. OA is nothing but H, that height of the right circular cone. OE equal to R. What is OE? It is base radius of that cylinder. And CE, height of the cylinder, nothing but H. Now, what next? Now these two triangles AOG and CEG are similar. So AO upon OG equal to CE upon EG. So H upon R is nothing but capital H upon R minus R. You can see the diagram once again. H upon R is capital H upon R minus R. See what is written? AOG and CEG. AOG, AOG and CEG. Is it? Which two triangles? Yes, CEG. They are similar. Yes, they are similar triangles. So using similarity, we write this relation. So we express capital H as what? H upon R into in bracket R minus capital R. Now, what is capital R? Capital R is expressed in terms of tan alpha. See, capital R is expressed in terms of tan alpha, where alpha is semi-vertical angle, and therefore H is nothing but 1 upon tan alpha into in bracket h tan alpha minus r. See, actually, this should have been together, that diagram and this explanation. So when you will write the solution, it will be with you only. Let V be the volume of the cylinder. Now, what is the formula for volume of the cylinder? It is pi r square h. That is pi r square. Replace h by this 1 upon tan alpha into h tan alpha minus r. So the function to be examined is what? V equal to pi r square h minus pi r cube upon tan alpha. Now we differentiate with respect to r, capital R. So what is the derivative? It is dvdr. dvdr comes out to be this. Okay. And what is d2v by dr square? It is nothing but twice pi h. Remember, capital R is the variable. So what is derivative of 2 pi rh? 2 pi h is constant. Now why I am taking h as constant? For the simple reason, small r and small h are the base radius and height of that cone. So cone is given and in that cylinder is inscribed, right? So capital R is variable, capital H is variable, and we expressed capital H, height of the cylinder, in terms of base radius of cylinder. Okay. Now for maximum volume, dVdr should be 0. So that equation is solved to get R as 2h upon 3 tan alpha. Now at that point, at this value of R, second derivative is found to be, you will notice that tan gets cancelled, twice, rather minus twice pi h, which is definitely negative. So the volume function has maximum when R is 2h upon 3 tan alpha. Now when R has this value, find the value of h. You will notice that it is h by 3. Hence, the height of the right circular cylinder is 1/3 of that of the cone. Okay. Sum number 17. This is an important sum. A wire of length L is cut into two parts. A wire of length L is cut into two parts. One part is bent into a circle and the other into a square. Show that the sum of the areas of circle and square is the least if the radius of the circle is half of the side of the square. I repeat the last part. Radius of the circle is half of the side of the square. Okay, write down. Solution. Let R be the radius of the circle, small r. Let R be the radius of the circle and x be the side of the square. X be the side of the square. Now see, one part is bent into circle, other into square. So can I say, don't write, can I say circumference of circle plus perimeter of the square must be equal to length of the wire? Yes, because one part is bent into a circle, so that for that we have to find the circumference, and other into a square, so perimeter. Okay, so write down. Then in bracket circumference of circle bracket complete, plus another bracket perimeter of the square bracket complete, equal to L, small l. That is, now what is formula for circumference? Twice pi r plus 4x is nothing but L, given means constant. So from this, tell me what is R? It is L minus 4x divided by 2 pi. Okay. Now sum of the areas. Therefore, sum of areas will be what? Area of circle plus area of square, that is pi r square plus what? X square. Now substitute the values and simplify. So this is pi. Now it is r square. Is it okay if I write directly? L square minus 8lx plus 16x square divided by 4 pi square plus x square. Is this correct? So tell me what next? Or you may say, sir, can we keep this as it is so that differentiation becomes easy? Yes, that can also be done. Now I simplify this to get at what? L square minus 8lx plus 16x square, because pi gets cancelled, upon 4 pi plus x square as it is. You can simplify this further or say that this is fx. So this function we have to examine for minima. Okay. Now next part, find f dash, f double dash. Finding derivative is not difficult because the given function is just a polynomial function. So this is 0 minus 8l plus 32x upon 4 pi plus what? 2x. I simplify this. That is f dash of x equal to what? Now I can divide by 4. So I can say it is 8x, right? Minus 2l upon pi. Is this correct? Yes, it is. Plus 2x as it is. Okay, this is f dash of x. Now I find f double dash of x. So what is f double dash of x? It is just 8 upon pi plus 2. So clearly, second derivative is always positive irrespective of the value of x. So will you say that the function is minimum for all values of x? No, we are using second derivative test. So the main criterion is first derivative should be 0 at this point. So I will say now f dash of x equal to 0 gives. Solve this equation and tell me what is x. 8x minus 2l upon pi plus 2x equal to 0. So what should be done? 8x minus 12 plus what? 2 pi x equal to 0. Solve this equation for x. Now I can take 2x common. Okay. So what I get is pi plus 4. Is it? Yes, equal to 2l. So what is x? X comes out to be L upon pi plus 4. Just check this. What is x? It is L upon pi plus 4. Now at this point tell me second derivative is positive or not? Yes, it is always positive. F double dash of L upon pi plus 4 is nothing but, what is that? 8 upon pi plus 2. Better we put this in bracket. This is greater than 0. So the function has minimum. So f has minimum at x equal to what? L upon pi plus 4. But this is not asked. We are asked to show that for minimum sum of the areas, the radius of the circle is half the side of the square. Okay. So let us find r at this value of x. So R equal to L minus 4x. So L minus 4L upon pi plus 4 upon 2 pi. Now simplify this. So it is pi L plus 4L minus 4L. This is how we subtract fractions. 2 pi into pi plus 4. See what you get here. So what remains is pi L upon 2 pi into pi plus 4. Pi also gets cancelled. So I can say this is half L upon pi plus 4. But note that L upon pi plus 4 is nothing but x. Yes. So we have proved what is required. Therefore, for minimum sum of areas, radius of circle is half side of the square side of square. That's it. Right done. Sum number 18. A rectangular sheet of paper of fixed perimeter with the sides having their lengths in the ratio 8 is to 15 is converted into an open rectangular box by folding after removing the squares of equal area from all the corners. If the total area of the removed squares is 100, so that directly gives me the value of x which is taken. The resulting box has maximum volume. Find the lengths of the rectangular sheet of paper. I'll read this sum once again. A rectangular sheet of paper of fixed perimeter with the sides having their lengths in the ratio 8 is to 15 converted into an open box by folding after removing the squares of equal area from the four corners. If the total area of the removed squares is 100, the resulting box has maximum volume. Find the lengths of the rectangular sheet of paper. Now see the diagram. See, these corners in the form of square are cut and then these are turned up along this, this one and this one. You get a cuboid box. Okay. Now the solution. Just listen to me. The sides of the rectangular sheet of paper are in which ratio? 8 is to 15. So we take them as what? 8K, 15K. Let x be the side of the square which is removed from the corners. Okay, which is removed from the corners. The total area of the removed squares will be what? X square plus x square plus x square plus x square. That is 4x square, which is given to be 25, which is given to be 100. As 4x square equal to 100, x square equal to 25. So what is x? X is nothing but 5, because x is greater than 0. Now the length, breadth and the height of the rectangular box will be what? Now let me explain this. See, the total we have taken as what? 8K. But from 8K, you have to subtract this x and this x. So this dimension remains 8K minus 2x. This total is 15K. I agree. But as these are cut, so from 15K, you have to deduct 2x. So this is 8K minus 2x one side, 15K minus 2x other side. And what is height of the box? X. That's it. Now what is the formula for volume of this box? Length into breadth into height. Okay. So volume is nothing but 15k minus 2x into 8k minus 2x into k. Simplify. So we have obtained volume as a function, polynomial function of x. Now the next procedure, dv dx is obtained. Since the volume is maximum when the side of the square is 5, since volume is maximum when the square of side x equal to 5 is removed, first derivative at x equal to 5 should be 0. See, I read this part again. This is dv dx. Okay. Now volume is maximum when the square of the side x equal to 5 is removed from the corners. This means x equal to 5 is root of which equation? dv dx. So I solve this equation. 12 into 5 square minus 92k into 5 plus 120k square equal to 0. So that gives me k equal to 3 or k equal to 5 by 6. If k is 5 by 6, then one side becomes negative, which is absurd. So k has to be 3. K has to be what? 3. So what is 8k? 24. And what is 15k? It is 45. So the lengths of the rectangular sheet are what? 24 and 45. Okay. So this is about the solution. Sum number 19, show that altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is what? 4r upon 3. See, this is the cone which is inscribed in a sphere. Okay. Let x be the radius of the base, x be the radius of the base, and h be the height of the cone, right? Which is inscribed in a sphere of radius r. Now observe this. What is AD? AD is nothing but h. This is height of the cone which is inscribed. And what is CD? CD is nothing but base radius of cone, which is same as BD. Okay. Now this is important. The next 2-3 steps are important. In the figure, triangle ABD and triangle BDE are similar. So AD upon BD, see, AD upon BD is what? BD upon DE. If you cross multiply, BD square is what? It is AD into DE. But what is DE? DE is nothing but AE minus AD. See, this DE is nothing but AE minus AD. Now note that AD is nothing but height of the cone. What is AE? This is diameter of the sphere. As radius of the sphere is smaller, what is diameter? 2r. And what is AD again? It is nothing but h. So x square is nothing but h into 2r minus h. I repeat this. See, there are two variables. One is radius, base radius of cone, and other is height of the cone. What is constant? Radius of the sphere, which is smaller, is constant. So we expressed x square in terms of height. Now volume of the cone is what? 1/3 pi radius square h. Do not write small r because small r is the radius of the sphere. Write small x, which is radius of the cone. So 1/3 pi x square h. But what is x square? This is nothing but h into 2r minus h. Substitute that. So we have expressed volume as a function of height. Now find out dv dh. Find out dv dh. 1 minute. Okay, so this is volume function and we find dv dh. dv dh comes out to be what? It is pi by 3 into 4rh minus 3h square. Okay. Now after this, we have to find second derivative. So let me find second derivative. It is d2v. It is d2v by dh square. Okay. This is nothing but, you will notice that it is pi by 3 is constant. I know you cannot see this. I'll show you the figure again. So it is pi by 3 into in bracket 4r minus 3 into 2h. So this is nothing but pi by 3. That's it. Pi by 3 into this cannot be simplified further. 4r minus 6h. This is what? Derivative of derivative. Now for maximum volume, what is requirement? dv dh should be 0. So let us solve the equation. dv dh equal to 0. What is that equation? Pi by 3 into 4rh minus 3h square equal to 0. So what we get, I will write directly, 3h square is 4rh. Can I divide by h? I can. So is it okay if I write h as what? 4r by 3. Okay. Of course, we have to mention that height cannot be 0. Okay. So h equal to what? 4r upon 3. What is at this point? At this point, what is second derivative? It is d2v by dh square equal to pi by 3. Okay, pi by 3 into what? Let me see the second derivative. See, this is the second derivative. Pi by 3 into 4r minus 6h. Okay, so pi by 3 into 4r minus 6h. So 6 into 4r upon 3. You will notice that this is less than 0. Therefore, function has maxima at what? At h equal to 4r upon 3. That is, altitude means height of the right circular cone of maximum volume is what? 4r upon 3.